Motors are fascinating devices that convert electrical energy into mechanical energy, and they play a crucial role in our daily lives. Let's dive into how they work. At the core of most electric motors is a simple principle called electromagnetism. When electricity flows through a wire, it creates a magnetic field. This is the foundation of how motors operate. Imagine a basic setup. You have a coil of wire, often called an armature, placed within a magnetic field created by magnets or electromagnets. When electric current passes through the coil, it generates its own magnetic field. This interaction between the magnetic fields creates a force that causes the coil to spin. This spinning motion is what we harness to do work, whether it's turning the blades of a fan or driving the wheels of a car. Now, let's break down the components of a typical electric motor. The stator is the stationary part, usually containing the magnets or coils that create the magnetic field. The rotor, on the other hand, is the rotating part, which is where the action happens. The rotor is connected to the output shaft, which ultimately transfers the mechanical energy to whatever needs to be powered. One of the most common types of motors is the DC motor. In a DC motor, the direction of the current flowing through the coil is switched periodically, allowing the rotor to keep spinning. This is achieved using a component called a commutator, which acts like a switch, reversing the current direction as the rotor turns. This clever design keeps the motor running smoothly and efficiently. Then we have AC motors, which operate on alternating current. Instead of a commutator, AC motors use the alternating nature of the current to create a rotating magnetic field. This field interacts with the rotor, causing it to turn. AC motors are widely used in household appliances and industrial machines because they are durable and require less maintenance. Now let's talk about efficiency. The design of a motor can significantly impact how efficiently it converts electrical energy into mechanical energy. Factors like the materials used, the winding of the coils, and the quality of the bearings all play a role. High-efficiency motors can save energy and reduce costs, making them a smart choice for both consumers and businesses. In addition to efficiency, motors can also be controlled in various ways. Speed controllers allow us to adjust how fast a motor spins, which is essential for applications like electric vehicles and robotics. By varying the voltage or current supplied to the motor, we can fine-tune its performance to meet specific needs. Finally, let's not forget about the advancements in motor technology. Innovations like brushless motors and stepper motors have opened up new possibilities. Brushless motors eliminate the need for brushes and commutators, resulting in less wear and tear and higher efficiency. Stepper motors, on the other hand, move in precise steps, making them ideal for applications requiring accurate positioning, like 3D printers and CNC machines. Understanding how motors work gives us insight into the technology that powers our world. From the simple fan in your living room to the complex machinery in factories, motors are everywhere, quietly doing their job and making our lives easier. The next time you flip a switch or start a machine, remember the incredible engineering that makes it all possible.